Okay, for this problem, we're given two equations. The first one, part A, is 6x minus 3y equals 12. And part B is y equals plus or minus x raised to the third power. We're asked to find, are these functions of x? Do these represent y as a function of x? There's two steps in doing this. When we're given an equation, they're really asking us, are all the ordered paired solutions to each of these equations a function? In other words, are the x's all faithful, teaming up with only one y partner? Well, let's do the two-step to find out if these are indeed a function. Part A, step 1, solve the equation for y. In other words, get y alone on one side of the equal sign. Okay, we'll move the 6x over to the other side by subtracting it. We get negative 3y equals negative 6x plus 12. We're almost there. We want to get y alone, so divide both of the two terms on the right side. Remember, terms are separated by plus or minus signs, so there are two terms on the right side. Negative 6x is one term and 12 is the other. Okay, we're going to divide both of those terms by negative 3. So negative 6x divided by negative 3 plus 12 divided by negative 3. Now simplify that. We got y equals positive 2x minus 4. Okay, everybody cool with that? Step 2 to find out whether this represents a function is to ask yourself, are the x's in this equation faithful? In other words, do all the x's, when you plug a value in for x in this equation, y equals 2x minus 4, does it produce one and only one y partner? The answer is yes. It is a function. It is a function because, BC means because, every x that you plug in there produces only one y partner. I cannot imagine any x that I could put in there that would give me more than one result for the y value. For instance, if I plugged, 5 in for x, I would get y is the partner to 2 times y is equal to 2 times 5 minus 4. 10 minus 4 is 6. So the y partner would be 6. 2x equals 5. The y partner is 6. And there's no way I'm going to get more than one y partner when I simplify after plugging any value in for x. Now let's do the same thing for part B, where we were given y equals plus or minus x raised to the third power. Step 1 is to isolate the x. Well, you know what? That's already done. We have y equals plus or minus x to the third power. I'm sure that's not as clear as I'd like it to be, but that's a plus or minus next to the x, and only the x is being raised to the third power. And the question is now, part 2, are the x's faithful? For every x that I plug in there, does it produce exactly one y partner? And the answer is no. It is not a function. It's not x as a function of y, because y is a function of x, because there are x's that will produce more than one y partner. Now, if you don't believe me, just think about this. We've got y equals plus or minus x, okay, to the third power. So let's say that x equals 2. That means y equals plus or minus 2, and just the 2 is raised to the third power, since there's no parenthesis around the sign plus or minus, just the 2. Okay, 2 raised to the third power. 2 times 2 is 4, times 2 is 8. So that means y is equal to plus or minus 8. Wait a minute, that means when x is equal to 2, y gets it gives us two y partners, positive and negative 8. One is positive and one is negative. Those are two different numbers. Okay, that means that we have an unfaithful x. We actually have many unfaithful x's, but just one is enough to mess it up for everybody. So this is not a function because there are x's that produce more than one y partner. And we are finished.